What's up, you guys? It's me, Abdul. It's been quite a bit, but hopefully everyone has been well. Happy holidays, and let's continue right where we left off in our last Unity tutorial. What we're going to be doing is continue refining the things that we initially did. So we're going to fix our jumping, we're going to work on our transitions between walk to running, we're going to work on our overall flow of the and script structure, as well as finish our animations and put them in nice and tidy and cohesive substates. So without further ado, let's move right along. So, okay, this is where we left off. And the first thing we're going to do is we're going to open up our Playercontroller Script. But before we do that, let's just take a look at things right now. So basically, you have the slow kind of animation. He jumps and it's all the same height. There isn't like, there's not a difference in the height based on the key press, which is not really the way the game is played. So what we're going to do here is Visual Studios is open, but not the script. So we're going to go here, go to our player controller, open that up, give it a second. Actually put this in a window so you guys can see. Hashtag dual screens. Okay, come on over here. So what we have here, right, we have a nice little compact script. It's kind of sloppy, but it'll do for now. So first thing what we're going to do is we're going to define a height that basically gives our player a nice wiggle room to get above the blocks and various obstacles. And we don't want extrusions and all this crap in our inspector. So we're going to make these two public float variables. We're going to make these, we're going to make these private. So what we're going to do here is just get rid of this, add a comma. Let me zoom in so you guys can see a little better. Get rid of this obstruction. Bring this down. And make a space between our public and private variables. So here, and we're going to change our speed. Let's keep that at 5, okay? And our height, what we want our height to be. Let's say 8.7 float units is a nice experimental range for both the various jumps that our player will be able to execute. I've already played with this and tested it numerous times, but if you don't feel comfortable with this or just want to go against me, do whatever you feel, but I personally feel that 8.7 float units is the best. So from there, we're going to move on and focus on fixing the jump. So basically, idealistically, what we want to be able to do is when the up arrow is initially pressed, basically if the player holds down, then we want the Mario to jump higher. If the player lets go initially, then we want a shorter jump. So to achieve this, other than manipulating the float value or the velocity being added to our object, what we're going to do is just change the gravity, which is also another way. There are many ways to do this. There's no one right way, but first off, let's go down and okay, let's go here. What I'm going to do is make a couple of things. So let's make some more booleans because we're going to need so. Let's just go ahead. We're moving right now, so let's add moving left. This is just for future reference. And from there, we also want to be able to know if the player has jumped. So let's say jumped, jumping, if the player is currently jumping, and let's say left stop. Oh no, that can wait for later. Okay. Grounded. Public static, public bool. Okay, bool. This can be brought down here. This doesn't need to be public anymore because it's just an extrusion. It's just a distraction. We don't need this. We got this. So basically, okay. What we're going to be working now is with jumped, jumping, and grounded. So let's go here, and this is already convoluted, and this is supposed to be like nice and readable, and it isn't. So what we're going to do is add a new function and just put this as state, and within here we're going to do a couple things. So basically what I want to do is be able to change a couple things first in the update function. So basically what we're going to do is go down to our code here, and if it says up arrow, then what we're going to do is going to bring this up to state. Okay. So what we're going to do here is get key. So we just want the initial. Instead of using get key down, we're just going to use get key initially. So if get key, just get key. If get key is pressed and if grounded is true, then we want jumped to equal true and jumping to equal true. Up, not minus, true equals true. And from here we're going to go down, and in our fix update where the magic is actually going to happen, we're going to copy this So basically we're going to go back to the way our code was. So rb.velocity equals new vector2, and we want to keep our current velocity in the x direction. That way if the player is moving right or left, then they will not stop moving the way they were moving, and add in our height float value, which we have already defined as 8.7 float units unless you've chosen to do otherwise. And from there what we're going to do is basically, okay, here's where the magic happens. If jumping equals true and jumped equals true, then we want to manipulate the gravity scale. Minus equals 0.1 a tenth float unit times time dot fix delta time. Okay. And one more thing that I did forget is we're going to go up here, and so there is an else if get key. So else jumping up jumping equals false. We can put that all on the same line just for convenience sake. Now that's ugly. Oh, that's still ugly, but okay. Oh, that's a little better. Okay. This needs sorry, I'm trying to make my code a little more decent looking. So jumping equals true, and jump equals true while the key is held down, but if otherwise, then only jumped equals true and jumping equals false. So if jumping equals true and jumped equals true, the player's jump and is still holding down the up arrow or whatever buttons you have then the gravity scale will a temp float unit will be subtracted from the gravity scale. Then what we're going to do is we also need another float value just for the sake of time purposes. So what we're going to do is we're going to make a float value called jump time, which is the maximum allowed amount of time before, let's just say, things get wonky and out of control and the player is able to infinitely manipulate their gravity, which is not what we want. So what we're going to do here is my code that I worked so hard to make pretty, go back down here and say that jump time equals time dot plus equals time dot delta time. So the time that has passed in frames based on frames. So this time will be different for each system and optimization, all that stuff. But generally, for the most part, it's correct. Okay. So jump time is going to be added, or the time that is passing currently in the scene is going to be added to jump time. So if jump and jumping equals true, and if jump time is greater than 1, jump time is greater than 1, then jumping equals false. And that will stop the player from being able to infinitely manipulate its gravity to infinity. So if jumping equals false and jumped equals true, if the player has yet to land on the ground, which we have no way of checking just yet, give me a second, work with me. Just imagine the gravity scale will gain 2 temps of a float unit just about every frame. So let's keep that in mind. So okay, what we're gonna do here is on trigger stay. So if grounded equals false, we don't want anything that's changed, but if grounded equals true, then jumped equals true, jump equals false, jumping, oh dang it, jumping equals false, and jump time equals 0. And the gravity scale equals 1. Basically, we want to encapsulate all of this into a nice set of curly braces that will make the job nice and dandy. So here, X tab. Okay, nice set of curly braces. And from there, let's just give it a gander, see how things are working. Okay, so our player, that's the maximum speed height we can jump. Nope, we're able to infinitely manipulate. So what is the problem here? Let's see. So state is not being called. Okay, so what we need to do here is state needs to be called every frame in our update function, and that should do it. So let's go back here.
2,000 years later.
Okay, so I figured out the problem to what we were having. So basically our booleans, thank God for the debug view in the inspector, which will let you see all your private variables without serializing them. Line 30 in our code basically is a parameter that, oh, well, no, sorry, I lied. Let's go back. Let's save. Okay. Line 30 in our code is a parameter, a conditional statement that does not actively allow the jumped and jumping booleans to register. So basically get rid of line 30 if your script looks exactly like mine, but not go to your state function, go to the if get key. In the line before that, if it says if grounded equals to true, then get rid of that. Save, and basically your boolean flag should start to register, so jumping and jumped should come up appropriately. But I'm having the problem where the jump time is not setting jumping to false, which is not what I want. So if jump time is less than 1, so if jump time is greater than 1 float unit, then I also tried changing jump time to plus equals time.fixed delta time to see if that made a difference. And let's see. You might have to play with some of these settings with the fixed update because every system is different, and since I don't know which you're running and what your computer can handle. So basically, okay, so you get the gist. So the longer I hold it, the longer it goes up. But thing is, if see here, jump time is over 8 minutes or 9 seconds, and that's unacceptable, and it's not doing its job, which is infuriating. Up, wait. So right now, jump time basically at like 7 seconds it starts. So let's see, jumping. It's not turning jumping off, which is the problem. So I don't know if this has to like encompass something. So okay, I see what I did wrong. So line 49 or my 49, where we're actually doing the physics that is behind the jump, above that we want to set if grounded is equal to true, and that should fix this, I think. So under line 48, just 49, pop in if grounded equals to true. That's if your script it looks exactly like mine, but if not, just go above the line that says rigid body dot velocity equals new vector 2 rigid body dot x and height, and yeah. So let's give that a try, and hopefully, oh, would you look at that? Yes, it works beautifully. So that's the highest it can go. It's going to 1 second, and then it's turning off. It's fixing itself. So here we have different levels of the jump: short, high, short, high, and I'm just playing. And this is all done through gravity, which is really, really nice because, like I said, there are multiple ways to do it. I've seen like adding force after a certain time has passed, so the button is still held down. Just a bunch of ways you could go about doing this. I prefer the gravity method because it kind of looks cool, just the way that they fall and the change in speed and everything. That's just my personal opinion. But like I said, if you figure out a way and you want to share, feel free to. Okay, with that said and done, what we're going to do now is, so now what we're going to do is, we honestly can put this all into its own void jump, its own function, just to clean things up because things are a little sloppy here and I don't really like things being sloppy. So yeah, let's just put that here, press tab, and this is encapsulated correctly, but this is encapsulated in a function. So let's get that out of here, shift tab. Okay, add in the enter, align this correctly, and then we should be good. Okay, there we are, we're good. And then we want to make the call appropriately, so jump. And let's see if it still works. Oh, sorry, I didn't mean to duplicate that. Don't scream at me, Windows. Okay, jump, we're good. So what I'm gonna do here is press play. I think I pressed play twice. Oh well. So, alright, and it works. So, yeah. Feel more than free to have some fun with that. And what we're gonna do is just minimize this and minimize our trigger functions as well. Our update and state for now, they're fine. Let me zoom out just a bit. That way I can see what's going on. And right now, basically what we want to be able to do is we're going to play with our speed a bit, because, I mean, even before we get into animations, just look how slow it is. Mario can't focus like that. And after a certain time, a certain amount of seconds, your speed does increase because you go into a run and it just feels natural. So what we're going to do is, one, I want to be able to clean this fix update the way that we're moving right now, because it's just kind of sloppy. So here, what I'm going to do is I'm going to make a new function called movement. And it's going to take in a vector3, and I'm going to call it dir, short for direction. And what we're going to do is basically, so we're going to make a integer, a private integer. It's going to be int. Oh wait, these are alphabetically out of order. It's driving me insane. So int move state. Okay. All right, so our move state, so we're gonna go to state and say if our player is holding down the right arrow, what we're gonna do is just here. We're not gonna call this. What we're gonna do is cancel this and cancel this. Matter of fact, we're gonna save one of these and just move it up and just put it into here for now, and change vector3.left to just dir. Okay, and from there we can get rid of these encapsulation curly brackets. What we're gonna do is gonna say here, so let's just add, so if the player is holding down the right arrow key, then we're gonna set move state equal to 0. Get rid of this. Okay, and then from there we want to be able to, let's just get rid of the moving right because we don't need that. So if the player is holding down the left arrow, we're going to set move state equal to 1, not -1, but equal to 1. Okay, so what does that mean? Okay, I mean, you've consolidated this code, but what does it do? So in our movement function that has a vector3 direction as a parameter, what we're going to do is basically, so before we touch that, in our state function, we're going to have a nice switch statement. And since this comes chronologically before the code, matter of fact, it would make more sense. Let's keep fix update under update, just because that just makes more sense. In movement, you would think that would happen before jump, and since jump does with a lot of Boolean flags, we're going to keep that below. So what we're going to do is keep everything to do with jump chronologically after something happens with movement, and we're going to keep state before movement, because your state can happen. Just yeah, don't question it. So okay, we're going to have a switch statement, and this is going to update every single frame because state is being called, and it's going to use thing with switch cases is that they're ordinal, so they have to be a value that's either an integer, character, or a boolean, so like on off. But if it's a boolean, then why not just use an if statement? I don't see the purpose in using a switch case statement for booleans, but as far as my understanding goes, they are ordinal conditional tests. Basically, if one value does not equal, then it will just chronologically go through all the cases, and if not, it will do a default or it just won't run. And basically it breaks the rest of the, it ignores the rest of the cases if one has already been selected. So what we're going to do is case 1. So if move state equals 1, then we're going to call the movement function and set vector and pass in a vector3.right, and that's going to be our direction, and it's that simple. And to handle our animations and stuff correctly, we're going to set moving right equal to true. And if you're moving right, then obviously you can't be moving left. We're going to set that equal to false. And then we're going to break our statement because it needs to be able to know when to terminate or to distinguish between the individual cases that it's going to see if the ordinal value that's being passed in aligns with the corresponding value that you're assigning it to. And if you don't use breaks, then it won't be able to distinguish between those cases. So if movement equals 2, sorry. This is wrong. In our movement, in our fixed update here, we have 0 and 1. So we're going to keep it 0, 1. So 0, 1. If movement equals 1, then that means we are going to the left. So vector3.left. Moving left equals true. Moving right equals false. And then we're going to break. And if either one of those cases are not met or being passed in, then we're going to default to moving right equals false. Moving left equals false. Walking equals false. Okay, that's going to come in later. We're going to go ahead and add that. Just black that out. So speed, we're going to set our speed equal to the default. Just break. Basically, if nothing's happening, then that means we're not doing it. We're just sitting here idle. So yeah, we're not doing anything. Okay, if that's the case, then basically we're going to let's go on to our movement function. And from here, what is happening is so you want to be able to, movement's going to handle the transition between walking to running, and we're going to want to do the same thing that was similar to what we did for our jumping. So we're going to want to be able to make Boolean flags that let us know when we're walking, the time and transition that's going to happen between the start of the walk and our final run speed. So let's go ahead and add a walking Boolean just anywhere in our list of Booleans. And this line is getting kind of long, so we're going to go before a comma and just, oh no, that just looks wrong. So after a comma and press enter. Okay, that looks better. And then in our float behind jump time, just add walk time. And what we're going to do here is go back to our movement. We're going to say when movement is initially called, that means that when either moving right or moving left are initially called, then walking equals true. So if walking equals true, speed what do we want speed to equal? So we're going to want to clamp, or we're going to want to restrict the value between its current default speed, what it's currently, the current speed that Mario is going, to let's say a float value. And what I found, once again, that 8 float units have worked the best for me. This is just me dabbling and experimenting. Feel free to experiment, but we're going to want to use mathf.clamp to restrict these values. So we're going to pass in speed. So that's the value that's going in, and then the minimum value that we want it to be, which is speed again, which is 5, or what speed will become over the rate of time. So we don't want it to go below that, because it wouldn't make sense for you to go a certain speed, slow down just to catch up to the maximum speed if you're trying to go from walking to running, if the player has not stopped walking. So we're going to set the max equal to 8 float units, and then walk time is going to equal time dot delta time is plus equal. So over the course of time, the walk time is going to increase. So, and from that, we're going to translate the transform of our character, or of our player, or Mario, from the direction that's being passed in to the speed, and then times dot fixed delta time, just to help consolidate some of the space. So similar to jump time, we're going to do a conditional check. If walk time is less than 3 float units, or 3 seconds, however, or 3 frames that have passed, not 3 frames, because there's like, it's not 3 frames, just 3 float units, 3 seconds. And if walking equals true, then we're going to want to set the speed equal, or speed plus equals 0.025 float units. Okay, and basically, else if walk time is greater than 3 seconds, we're going to set speed equal to 8 float units. So we're here clamping the speed from its current value to 8 float units, so that way no matter what happens, it will not pass 8 float units. And then we're going to set the walk time, which is initially 0, and add it over the course of the duration that movement is happening. So from the time the player has started moving left or right, then their transform is going to be translated accordingly to the vector 3 that's being passed in. And then if walk time is less than 3 seconds, and if walking equals true, then the speed will be 0.25 float units will be added onto the speed each frame that is being called. And then from there, if walk time is greater than 3 seconds, then speed will equal its max value. So from here, what we're going to have to do is go back to our state function and be able to specify a couple things. Go back to the default, and if movement right and movement left isn't happening, then 1, we're not walking. So walking equals false. And if walking doesn't equal false, then if walking does equal false, then the time that has passed since the player's walked is 0, or initiated walking is 0 because it's not walking. And we're going to set our speed back to 5 float units. This is necessary to help us learn or help us keep the player from going all the way up to the max run speed, stop walking, and then continue to walk and not have to go through the initial conditional check with the walk time that has passed since it started walking the second time before it can just go full speed. That way it keeps things kind of consistent. So let's play with this. Let's see what's going on. Okay. We're having a problem. Basically, our player is infinitely running. So what we need to do is our state is not being our state is being manipulated. So let's go back to our fix update. Let's go here. Okay, so basically 0, we want a placeholder variable, a placeholder slot for movement or the move state. So what we're going to do is change these cases from 0 to 1 to 1 to 2, and then we're going to go to our fix update functions and change these from 1 to 2. And then we're going to go below that line and say if. So what we're going to do is just combine these two. So copy, paste. All right, and then we're going to delete this and then copy and paste. And then what we're going to do here is press enter, and then so basically, so what I'm gonna do is in front of every single input, I'm just gonna put an exclamation point, and which means the opposite of true or the opposite of what is. So if input.getKey keycode.right arrow equates to true, then exclamation point in front of that means that it's false. So if this is false and this is not happening, and if it's false, it just means it's not happening, and this is not happening, and if this is not happening, then we want move state up. Let me get rid of that extra. We want move state to equal 0. So if the player isn't pressing the right arrow, if the player isn't pressing the D key or the left arrow and the A key, then what we're going to do is set move state equal to 0. And be sure that your encapsulation of parentheses is correct, because you have two OR statements being checked while both conditions are being checked to this AND, which does take precedence. It does take precedence if your parentheses aren't set up correctly, but initially, if things are done right, basically what's inside of the parentheses will take precedence based on the order of operations. But either way, based on what we're trying to do, it's not the end of the world. You'll just probably get a syntax error, so watch out for that. So let's give that a gander now, and we should be able to do what we need. So basically, yeah, click on the screen. Okay, I'm able to jump. I'm not able to do anything. So let's go back here. Okay, so I figured out the problem. On this last conditional test that we've done for the move state, where we set move state equal to 0 if the player isn't pressing any of these keys, this AND, these two sets of ampersands, needs to be or. So let's try that and see if that works. And it does not. Okay, back to the drawing board. Okay, so I know the problem. Since move state is just defined and it doesn't have initial value, this is a problem. This is something that's just done in C-based languages, and they expect you to know this, and you won't get a syntax error because they expect you to know what you're doing. Not so much in C#, but C++ especially. Move state doesn't equal anything before this is happening. So basically, it's just like gobbledygook. It doesn't have a value assigned to it. So when I'm assigning move state initially to 1, if this condition equates to true, and if this condition equates to true, and if this condition equates to true, if those values are being assigned based on that, by the time move state is called, the switch statement that takes in move state as a parameter doesn't know what to give it besides it just equates it to this. Even if this condition is that we've said basically if moving right or left isn't happening and move state equals to 0, well, this just makes a sort of problem. So basically, to fix this, to put this rant to the end because I'm just confusing myself, we're just going to put this above as the very first condition check. So if none of the input keys are being pressed, then move state equals 0. And if that's the case, then this will happen. And we're going to save our script, go back and see that it works perfectly. And basically what we're going to do here is, here I'm going to get rid of this brick block. So get rid of it. And basically, as you can see here, after a certain amount of time, our player is increasing. And if you don't believe me, then let's click on our player, go to the debug, scroll down. You can see here the speed is 5. Go here. It is slowly increasing to 8. 8.25 is its max, which it's not perfect, but hey, it'll have to do. This will look a lot better once we get the animations to appropriately equate for this change that's happening. And yeah, this tutorial has been long enough, and I thought I was going to be able to get to it, but that just means I will see you in 14. So hopefully this has helped. Our script looks a lot nicer. Holy crap, it looks so much better. You have no idea how ugly and just pathetic looking that script was. And the fix update and update is nice, happy, and clean. And so our movement functions and everything, this is really nice. I enjoy this, and hopefully you enjoy it too. And I hope to see you guys in the next tutorial, which is coming soon, and we will finish the animations as well as the substates. And then from there, once we finish the animations, we can go on to adding the sprites and animations to the rest of the enemies and getting the box colliders correct, and basically just changing Mario's state with the power-ups, because the box colliders have to appropriately conform to the sprites, and that can get a little nitpicky. So prepare to do some sprite, or you can just keep it with the blocks and just watch and follow and say, oh, that's cute. Totally up to you. But anyway, yeah, save your script, save your scene, up, not your, yeah, save your script, save your scene, and I hope to see you all, and yeah, be sure, take care. All of this will be on GitHub, especially the assets that I have used so far, as well as the assets that are coming up. They will be in a link provided below, so be be sure to check it out. And if you don't know how to use GitHub, there is a tutorial up on my channel just for you, and there are GUI tools, that way you don't have to hardline a single piece of code in Git shell. So without further ado, I will see you guys later. Take care.